Okay, here we are with the third video of the semester. And today we're going to be talking about amortization of loans and stuff and sinking funds. Okay, so let's talk about amortization first. So simply put, amortization amortization refers to the amount of principal and interest paid each month over the course of a loan's term. And what you really note when you look at amortization or amortization tables, which we'll get to in a minute here, is you note how interest payments decrease over time. It's kind of interesting to see. So here's the idea. We think of, student loan is probably the best one to think of because we all have it. And let's think of paying back a student loan. So a motivating example here. If you think of these monthly loan repayments, are as payments in an annuity, then the original amount of the loan is P, the present value of the annuity, if you're thinking of these as annuity payments. It's just a thought here. Okay. So from the last section, the present value of an annuity is given by this formula. Make sure I do this right. I keep writing it wrong. Okay. With the normal definitions of what P, R, I, and N are. Okay, so now let's think like a bank. How much, and ask the question, how much should your monthly repayment be? So your monthly repayment bill to amortize your loan at the end of the term. Okay. So, come here. Where'd it go? There it is. So if you think of this formula here, so all we do is solve, all we do is solve the star above that formula for R. That's it. So multiply both sides of the equation by I, and you get PI equals R times 1 minus 1 plus I, then minus N. Dividing by that number, you get R equals PI over 1 minus 1 plus I to the minus N, like that. And this is your monthly payment. And when I was trying to buy my car, I wanted to have my monthly payment at a certain number. So I used this exact formula with all the stuff they gave me to figure out how to get it down to the number I wanted, and then adjusted my down payment to make it work. So and here I am 1 month away from paying it off. Okay, and it's cool to make a schedule of how this goes. I'm going to ask you to do some computing. Really easy stuff, just to get the ball rolling with that. And here we go, one example, and you'll see this is almost exactly the thing we've been doing. So let's say you borrow $50,000. You get a 5-year loan, and you pay back at 8% interest. And just to make the numbers kind of easy, we'll up it in the homework and other examples. But so let's say we make one big payment a year for these 5 years. So at the end of each year, you make a payment. And let's find what are these payments. Right, so just to be clear, you borrowed $50,000. It's a 5-year loan that you have to pay back. You make one payment a year at the end of the year, and you're charged 8% interest on whatever your principal is. Okay, so we run our formula. Plug in the numbers. So the principal of our loan is $50,000. The I, which is the interest rate, is 8% or 0.08 in decimal form. Okay. Now we have 1 minus 1 plus I. Now I is R over N, but N is 1. So in this case, it's just 0.08. And then minus 5 is number of years, or number of compounding periods. And you plug all that into your calculator, and you get $12,522.82. Okay. And you pay this once a year for 5 years. And this pays off the loan. And of course, you're paying a lot more than $50,000 back. That's how this works, right? This is how banks make money. So we're going to make what's called an amortization schedule. I'm going to do this one by hand. You can use Excel or R Cloud. I'd rather you use R Studio. This is the better one. So here we go. You see how this rolls. So our first column is the period. 1, 2, 3, 4, 5. So there's 5 periods of the loan. And then we're going to compute the interest, the repayment, how much you pay, and then this column will be payment toward principal, and then out here will be the outstanding principal. And so we just put the 0 column here because we're starting with 50,000 bucks. Okay. All right, so at the end of the first year, you get hit with your interest. So the interest on $50,000 is, I'm gonna use my trusty calculator here, times 0.08, and you get 4,000 bucks. All right, so in that first year, you got $50,000 to spend, and now you've been hit with the $4,000 interest at the end of the year. Okay, but then you pay $12,522.82. Okay, if you subtract off the interest, then you paid what? $8,522.82 towards the principal. And now take 50,000, subtract that, and you get 4,147,718. So you see your first $12,522, 4,000 went to interest, and 8,500 went to the principal. Okay, so at the end of year 2, you take that $41,477.18 and you compute the interest on that, and it's $33,18.17. Okay. You make your payment. And then you go 12,522.82 minus 3,318.17 gives you 92.04. And then you subtract that off. And now you get 32272.53. So note that the interest went down here. The amount of interest you paid went down, and the amount towards the principal went up, and that's good. All right, so we just wash, rinse, and repeat this. This gives me 2581.80. Make our payment here. 9941.02, 22, 331.51. Compute again. And then last year, sorry, you do the same thing. And well, there's a penny left, so you paid it off, and that's how you compute. That's how you compute your R. Okay. And yeah, if you used Excel or RStudio, you could set up this little table and pretty quickly. It's not that hard. It's just some adding and subtracting of the columns. All right, so that's amortization. And now we're talking about sinking funds. This is kind of cool. I've never heard of this before. I guess I have. I didn't know it had a name. So start with the definition here. A sinking fund is an account set up for a specific purpose at a later date. We did this at a place I worked at when I was an electrician. We always knew we had big trucks and things that we had to buy in the future and replace because you're driving around all day and you wear stuff out. And so if at the end of 5 years your truck has got 200,000 miles on it and it's trashed and you haven't saved up money, you got to buy a new one, and it's a pretty expensive one-time purchase. So if you've got a sinking fund, we just didn't call it that, where you're putting money in monthly towards that sort of thing. It's like an emergency fund, but it's a planned emergency fund. Then when the 2 years or the 5 years is up and it's time to buy your new vehicle or new pipe threader, you got the money. So let's do an example here. And basically what we're doing is we're looking for the size of the payments to fund a future value of an annuity. And that's the only real tricky part here. So let me talk about that for a second. Whereas before we said we want to know what the present value is to figure out our loan repayments. Here we're looking for size of the payments to find the future value. So we already need to have all the money in the bank when we buy it so that we can pay for it. So this is key. You're looking for size of payments to fund future value of an annuity. S. And so instead of using the present value formula, now we use the future value, which says S equals R 1 plus I to the n minus 1 over I. And here we solve for R. Okay. Very similar to the last one, only now we're using the future value of the annuity and not the present value. And so when you turn this around, it looks almost exactly the same as the other one, but it's different. 1 plus I to the positive n minus 1. And this will be the green formula. I am putting together a document with all these formulas on it that I'll put on the back of your first midterm so that you have all the formulas given and correct. So when I get that sorted, there's a few more that need to go on it. I'll post it on the blog at the blog page, and then you can have it to study with or use for. It's nice to have all the formulas in one spot instead of flipping through papers. So let's do an example here of a sinking fund. This is just what I was saying before. Let's say there's a hardware store. So Cole Hardware needs a new truck. In 2 years' time. I think they're expecting it to cost $30,000. So in 2 years, they know it's time for a new truck, and they sussed out that they need $30,000 to buy this thing. So now they want to start saving regularly for it. Okay. And while they're saving, they're making money. So if the fund, the sinking fund, earns 10% per year, quarterly. Determine the size of the installments. All right, so what they're saying is they found a mutual fund that pays 10% per year, and they're going to pay into this thing monthly or quarterly, and so that at the end they have $30,000, and along the way they maybe haven't put in 30,000. They've put in a lot less than that, made money along the way, and helped themselves make this one-time purchase. Okay, so now we have R equals SI over 1 plus I to the n minus 1, and this equals S, which is 30,000. I, which is 0.10 over 4. Let's see here. This is equal to 0.025. So down here we have 1.025, and then 8 is the number of periods because it's quarterly for 2 years. And this gives us 34 OT. O2. All right, so yeah. So at the end, all they paid in was what is it? 27472. Oops. 30,000 minus 27472.16520. So if you take the 30K and subtract this, you get 252784. So they saved, they saved 30,000. They saved $2,500 roughly, doing it this way and using the sinking fund. And at the end of the 2 years, they had the $30,000 to buy their new truck. Okay, so this is already posted at Brightspace. So this is homework 2. This is the second part of it. It's from section 5.3. 19, 24, 29, 30, 34, and 55. And so also add for pick one. Pick one of these amortizations. So there's, I think, 3 amortization and 3 sinking, or 4 and 2, I'm not sure. So pick one of the amortization problems and produce, after you answer it, produce one of the amortization schedules, just to get practice doing it. And I'll have a few more examples when I meet up with you in a minute.